multiplying and dividing rational expressions. Basically, we're going to be looking at stuff like this, and we're going to need to simplify that. So, it's a real sunny, glary day. This will probably be easier. Whenever we're going with problems like this, where we're going to be having to simplify stuff out, the first rule of all of these things is going to be the same: factor. So when you see these types of problems, instead of writing down the original problem as you go, factor it as you're starting. So if I'm looking at that numerator, what times what's negative 12 that adds together to get negative 4? Negative 6 and positive 2. I'm going to start by writing the problem out in my notes or on my homework or whatnot by factoring it as I go. X minus 6, x plus 2, over x minus 2, x plus 2. Very good. What simplifies out?
X plus 2.
X plus 2. Now, can I simplify those two? Can I basically cross them off? Can I simplify over multiplication? Can I simplify over addition? No, that's what you guys like to do, and you're always wrong. And you're done. Your answer is x minus 6 over x minus 2. And you've simplified it out. Again, you probably have seen this some form or another. Maybe not with the larger factoring, but you might have seen it with just GCFs in the past. Okay? Same idea as we get into multiplying things together. If I'm multiplying monomials, this is going to mirror the same stuff that we did in chapter 6 or in chapter 7 with your exponent rules. Remember, when we did that stuff, we always dealt with what first? Well,
The exponents.
no. Numbers. When you get to these types of problems where you have these nasty monomials being multiplied together, one of the things that I always tell students to do as you're writing it down, put your numbers together, put your variables together. Start matching the things together, matching them up. So I know that I'm going to get, well, 5 times 6, I get 30. I have x squared, x to the third. When I multiply them together, what do you get for your exponent? X to the fifth, good. Y times y squared, y cubed, over 20. Just one value of x, and I have y to the fourth. What I've done there is I've basically multiplied the numerators together, multiplied the denominators together. Take care of your numbers first, because it's always the easiest. Now I start playing those rules of simplification. 30 over 20 should be very easy to simplify. If you can't do that, could you put that in your calculator, hit math, enter, enter, and it'll do it for you?
Yes.
Do we all agree this is 3 halves? Right? Now, what do you do when you're dividing with those exponent rules? Play war, good. So in that first one, x to the fifth and x, who wins? So it becomes 5 minus what?
1.
Good. So what do we get? Does it stay in the numerator or does it go to the denominator?
Numerator.
Good. And then lastly, y to the third, y to the fourth, who wins? So yeah, I heard someone say the answer is y, and he gives us y in the denominator. And that's it. Again, this is not anything really different than what we have done. What you guys started with in chapter 6 and in chapter 7 is you started with this scenario and you simplified it out. Whereas in this case, we're starting with prior to it where you have to multiply it out and go. All right, does that make sense? Okay. When you have to do multiplication of all this, when you get some nastier looking stuff. In this case, there are 4 different parts. Well, there's 2 numerators and 2 denominators. For each one of those, I'm going to be looking at it. Can I simplify, or can I factor something out? Can I write it in different forms? Can I write each one of those in its simplistic form prior to multiplying? Because you don't want to distribute all that out and then try to factor. You always factor first. So that first numerator, 4x minus 4x squared. If I'm going to factor that, what do I do? Yeah, GCF. All I can do is the GCF in this case. In this case, in this numerator, all I can do is take out the GCF, and I get 4x, and I'm left with 1 minus x. Does everybody agree? Okay. The denominator there. What times what's negative 3 did I add together to get positive 2? Good. X minus 1, x plus 3. Next numerator. What times what's negative 6 you add together to get positive 1? Very good. And then down here is just the 4x. Nothing I can do. Now, again, since I'm multiplying these two fractions together, it's basically everything in the numerator is all in the same numerator, everything in the denominator is all in the same denominator. So now I can start looking for stuff to cross off. I'm looking for pairs of 1 that I can simplify out. What can I cross out? X plus 3s?
Yes.
Okay. Ooh, x minus 1 and 1 minus x, is that the same thing?
Yes.
Good. X minus 1 and 1 minus x is not the same thing. Okay, it's not going to be the same thing. Because if x is 3, you get negative 2 or positive 2. Same. I'm done. My final answer winds up just being, I don't have to multiply this back out. That's just a waste of time. 1 minus x, x minus 2 over x minus 1. I'm done. It's very exciting being back. isn't it?
Wait, that top left set,
Yeah.
what did you do to simplify it?
I just took out the GCF. The all they had in common was the 4. Bless you. The only thing they had in common was the 4x. There wasn't any. It wasn't like a difference of squares that I could factor out that way. It didn't work any other way there. Okay. Remember, first rule of factoring is always GCF, and then go from all the other stuff. Do you guys remember? Oh, here. Take a minute. See if you remember how to factor a difference of cube.
Don't you have to?
Oh. So remember, yes, there will be times that you have to remember little bits and pieces here as far as your differences of cubes. So if it's a cubed minus b cubed, it's always the same. Change it, positive. Oops. In this instance here, my value of a is what? What's the value of a going to be here, guys?
A is 1.
Is it 2x? The value of a here is 2x.
Oh.
A value is 2x, because that's the first term, because 8 is a perfect cube. So it's 2x, so it winds up being your a value is 2x. Your b value is 1. So when you factor this stuff up, you get x plus 3 over.
Wouldn't it be negative one?
Oh, I just said the b value was 1. I was just saying the b value is 1, because I'm not worried about the, remember we're doing difference in squares, you're just looking at the a values, first term, b value, second term. The sign values change within the pattern, just worrying about the stuff there. So we wind up with 2x minus 1 times, well, 4x squared plus, excuse me, yeah, plus 2x plus 1. Oh boy, look at this. Wow, that is crazy, isn't it? Yes, sir.
Oh, wow.
Positive 2x.
The pattern for doing sums and differences of cubes for factoring out, difference of cubes always follows the same pattern. Same sign, opposite, positive. So it starts out with minus, plus, plus.
So you kind of ignore the negative in front of 1.
Yeah, because the b value is just 1. The a value is 2x.
Oh.
That's all it is.
It's not negative 1.
No.
Okay.
No. Same thing with the sum. Yeah.
Wait, why wouldn't it be -1? Or is it just because it's minus b?
Correct.
So then
Because it's just minus b.
Okay.
All right. Now, what I'm saying here kind of sarcastically is that once you remember that pattern, this whole term goes away, and you're left with just x plus 3 over 2x minus 1. You all right? Welcome back. It's that extra 2 days that, you know, if you guys were here on Monday, you would have been fine.
Especially
Albeit maybe a little frozen, but you would have been all right. All right.
Well, I mean, all you had to do is not walk out in the cold after an hour. You'd be fine.
Ish. What changes when you divide? When you divide fractions? Yeah, you have to worry about reciprocals. So my suggestion to you guys, every time you see a division problem, you never write down that it's a division problem. When I go to write this problem down, the first thing I'm going to do is my same, change, and flip it. Remember, whenever you're dividing fractions, you're multiplying by reciprocals. Don't write out the problems with the division symbols in there. Automatically flip it to becoming a multiplication problem. It'll make your lives easier. You'll be less likely to mess something up. Now, granted, if you want to take it a step further and as you're writing this stuff down, factor it as you're going, go for it. I know most of you guys will do that anyway. Again, as we're starting up these types of problems, you need to factor first, and your first rule of factoring is always to look for GCFs. So the first numerator, I have a 5x. There's really nothing I can do with that. The second, the first denominator, I have 3x minus 12. What can I do there? Factor out the 3, good. So I wind up with 5x over 3 times x minus 4. All right, what times what's 8? You add together to get -6. -4, -2, good. And then in the denominator, what can I do there? Take out the x. All I can do is factor out the x, and I get x times x minus 2. And now we start seeing what we can simplify out. What goes away? X minus 2's, good. X minus 4. Anything else? X, good. You get 5/3.
Oh,
Sure. Okay. It's exciting, isn't it? All right. Try this one then.
3 hours.
Take a second, try that one out.
5 hours.
Yeah, I know most of you guys probably weren't even awake yet by now. Remember, when you are doing these types of problems, when you set these things up, when you have that leading term coefficient that is not equal to 1, just take the first and the last term, multiply them together to get 18, negative 18 in this case. So now, what times what's negative 18? You add together to get a positive 7. 9 and negative 2, good. So when you go to factor this one out, the easiest way you do this, it goes 6x squared minus 2x plus 9x minus 3. Now, the reason why I'm doing it this way is because I'm factoring it by grouping. When I factor by grouping, I wind up doing GCFs twice. I always like to put my negative term first because it's a little bit cleaner. Doesn't mean you have to, it's just a little bit cleaner. From here, when I group this out, I take GCFs. I get 2x, and I'm left with a 3x minus 1.
How did you get the 2x in there? Because I can see like 2x plus 9.
6 times negative 3 is how much?
Oh. 9.
No.
No, wait, it's 18.
No.
Did it?
Negative 18. What times what is negative 18? You add together to get a positive 7.
I'm just gonna stop before
So now you wind up with that, and you see how you've got the terms that are the same within the parentheses, the 3x minus 1s? So now your numerator becomes 3x minus 1 times 2x plus 3, and that's the factored form of that. Okay? From there, you can just go ahead and continue. Put that back over to the 6x squared. On the other side, I'm dividing by 2x squared plus 3x. That becomes times 1 over, what can I factor out? X.
Wait, what times what equals negative 2?
6 times negative 3.
Right, negative 2.
Yeah.
But then,
9 times negative 2.
okay.
And now I'm left with that. Does anything drop out? A 2x plus 3. So you're left with now 3x minus 1 over what?
6x.
6x is the third. Very good. Can I do anything else here?
Can't you make it, or can't you play more with the x's?
No. I cannot do any more here because of the subtraction symbol. There's no,
6x.
no, because it still had that subtraction symbol.
Oh, okay.
Okay? Because you cannot simplify over addition or over subtraction. When you get to this point here, you're done. The only thing that could have happened is, let's say with that 3x and the 1, there might have been another GCF maybe we had missed. Sometimes you might get to a point there, you might be able to factor out another 2 or something.
Okay.
That's the only time you can do that. The only time you can simplify like this is if it's monomial, like straight multiplication setups. You cannot simplify over addition or subtraction.
What if it didn't have that, and then, let's say like.
If it was just 3x over
it did have
6x cubed,
coefficients.
what's that?
Like, let's say they did have coefficients like 6x squared.
Guys.
Over 6x to the third.
I'm sorry, you have to repeat yourself again.
If it's like 6x squared over 6x to the third.
Then you can simplify that because then you
the
can,
x, or
yeah.
over x.
Because then you're looking at monomial over monomial, and then you're going back to those, using basically your exponent rules
Okay.
from back in chapter 6 and chapter 7.
Alright.
That's fine, but as soon as you tack on here where you have a binomial, you can't do that simplification anymore.
Okay.
All right? Yes, sir.
I have 2 questions. First off, is this as extreme as it gets? Or is this, Alright. Also, do you have homework that you assigned over vacation? No?
This is about as extreme as it gets because then it starts mixing together, multiplying and dividing. Okay? Yeah, exactly. It winds up being, it looks like it's going to be really nasty, but it's the same exact idea here. When you have multiplication and division thrown together like this, remember, the order of operations tells you to multiply and divide in the order in which you see it, but when you're dividing fractions, what are you doing? You're multiplying by the reciprocal, right? So in this case here, as I'm writing this problem out, this first group, x and x plus 5, there's nothing I can do. So I just write x plus 5, times, well, 3x minus 5 over 1. Can I put that over 1 there to kind of keep everything in line? There's nothing with the 3x and the minus 5 that I can factor with. There's no GCFs. But then the last term, I get x plus 5 over what? Very good. Notice how that's a difference of squares? 9x squared is a perfect square. 25 is a perfect square. It's a subtraction symbol. You get 3x minus 5 and 3x plus 5. Again, now is when you start simplifying things out. You'll start to do a lot of crossing off. Your final answer is x over 3x plus 5. Now, Lance, this is the same idea like we were talking a second ago. It's monomial over binomial. I cannot simplify anything any further.
Okay.
So it's just coincidence, it's the exact same thing as the formula. You see what I'm saying? Never mind.
Is there a 3 here?
No, I noticed that after.
3 here. So are they the same? Like kind of same-ish. It is coincidence. You're going to see this. Sometimes you might simplify everything out and get 1 for an answer. Sometimes you're not going to be able to simplify anything out. You just get this nasty-looking thing.
Then, like I know you explained it before, but why can't you take that
because it's part of a binomial, there's two terms there. When you have the 3x plus 5, there's nothing left between the two of them that are shared. I can't factor anything out. The x is a monomial, it's a singular term. Even though there's no, it has an x1 of 1, but there's nothing left for itself to be factored out as well. You cannot simplify, and this is when you hear that term, you cannot simplify over addition and get 1/8. Won't work. All right. When you have monomial and a binomial, you're usually not going to do anything any further at all. The only time that it could happen is if you missed a GCF not in one of those two. Sometimes that will occur. But when you get to this part, you're done. It doesn't simplify any further. Yes, sir?
So if they were both binomials and they just have different powers?
There might be something you can do. Now, what I'm saying here is if this was x minus 4 over 3x plus 5, there's nothing I can do. There's no GCFs, there's no nothing. But for instance, let's say if there was an even term in both of them, you could have factored out in 2. Sometimes that occurs. But when you wind up with this, you just cannot simplify any further over addition. You can't do it. We'll just leave it as that.
Okay.
And this one.
Wait, does it simplify it?
And now the fun part. Making yourself feel good. And you're done. That's it. Okay. What I want you guys to do tonight, I remember if I had them all written out here or not. Yeah, that works. Every other odd. Okay?
I know, it's fine.
Yeah, I'm talking about something like that. Let me stop this.